Hello again. Today we're going to be talking about how to find the derivative of an inverse function. So let's get started. Let's start with an actual function, which I will just arbitrarily call f of x. And let's say that that's the graph of f of x. Well, knowing what I know about inverses, if I switch the x and y coordinate of each point on f, I will get the inverse function, which is f inverse of x, and it's in the blue on the same graph. So if I pick any point on the inverse function and let's say I want to find the slope of the tangent line for that point. Well, I'm randomly going to call the x-coordinate a so that the y-coordinate would be f inverse of a. Now I can trace that back to the original graph, and so the x and y coordinates would be switched. So my new x-coordinate on the original function would actually be f inverse of a, and the y-coordinate on the original function would be a. So if I know what the f function is, then I can figure out what the slope of the tangent line would be at that red point on the graph. So just looking at the slope of the tangent line, which I've drawn there, generically that's going to be f prime of x. I want to know what the slope is at that point, so I plug in the x-coordinate, which is f inverse of a, and that will give me f prime of f inverse of a. So that's going to give me the slope of that tangent line. Okay, so how is that related to this new blue line that I've drawn on f inverse? How are those slopes related? You can see that they are related, but how are they related? Well, the rise and the run have simply switched places. So rise over run, that fraction can be flipped upside down to get the slope of the blue line on the inverse graph. So it's actually going to be 1 over what I calculated for the red curve, for the slope of that pinkish line. So it's going to be 1 over f prime of f inverse of a. So that generically is going to be the formula to figure out the derivative of an inverse function if I know the original function. It's probably going to make more sense if I go through some examples, so let's do that. So for example, if I have f of x equaling e to the x, then I need to show that the derivative of natural log of x, which is the inverse of e to the x, show that that is 1 over x. So I know that if f of x is e to the x, then the inverse is natural log of x. I also know that if f of x is e to the x, then the derivative of that is going to be e to the x as well. So the derivative of the inverse of x, I'm just going to plug in natural log of x for f inverse, and I will get f prime of the natural log of x. So I'm just plugging that into the derivative, and I get e to the natural log of x, which is x. So that is f prime of f inverse of x. Now remember, the slope is actually 1 over that. So the slope is going to be 1 over x. And that kind of shows that the derivative of natural log of x, which is the inverse of e to the x, is going to be 1 over x. Okay, here's another example. Let's say I want to show that if f of x is x to the third, then the derivative of x to the 1/3 is 1 over 3x to the 2/3. All right, let's see how we can do that. If f of x is x to the third, then the inverse of that is x to the 1/3. Also, the derivative of x to the third is 3x squared, which we know. So I'm going to plug in the inverse into the derivative, and I will get 3 times x to the 1/3 squared, and that gets me 3x to the 2/3. All right. So 1 over that is going to be 1 over 3x to the 2/3. All right, as a last example, let's look at a table. All right, so let's say I don't actually have a function, but all I have is a table of values, some x's, some function values, and some derivative values for those x's. So if I have this table, what's the equation of the tangent line to the curve of f inverse at x equals 5. So I have to be careful here because I have 2 rows, one of which has an x of 5 and one of which has a y of 5, but that's for f of x. So I have to look at the row that has a y value of x, because if 13 and 5 is on the graph of f, I know that 5 and 13 is on the inverse graph. So I have to keep that in mind. The slope of the tangent line of f at this point is going to be 3. So on the inverse at 5 and 13, the slope is going to be 1 over that, which is 1/3. So I have my x, which is 5. I have my y, which is 13, and I have my slope, which is 1/3. So I have my equation line, which is y minus 13 equals 1/3 times x minus 5. So that is how to find the derivatives of inverse functions. If you have any questions, please let me know, and I will see you tomorrow.